Good evening, all. So, welcome to the day 4 of International Congress on Industrial Perspectives of Data Analytics. Resource person is ready.
Yeah.
Sir, welcome, sir.
Good morning, good evening.
Yeah.
Happy morning. Early morning.
Good morning, good morning.
Good morning. For the resource person, the rest of the people, happy evening.
Resource person is ready. Yeah. Sir, welcome, sir.
Thank you.
We'll start within another few minutes.
Sure, no problem. Can you hear me okay? Your audio is good?
Yes.
Yeah, good.
Okay.
Good afternoon, ma'am.
Good afternoon, sir.
Welcome, sir.
Welcome.
afternoon.
Thank you. Good afternoon.
Thank you, sir.
So, shall we start? Yeah. Bhavani?
Education is the key that unlocks the golden door to freedom. A warm good evening to one and all present here. I am behalf of Department of Computer Science, MHRD, RUSA 2.0, Biomaterial, Team 2. Welcome you all to this International Congress on Industry Perspective of Data Analytics, Day 4. Nobody built like you. You design yourself. You are a role model for everyone. I'm glad to welcome our Professor Dr. P.L. Chitra ma'am Principal Investigator, RUSA 2.0, Department of Computer Science, University of Madras, introduce our resource person of this day, Mr. V. Subramanian, Senior Technology Manager, Honeywell International Inc., Atlanta, US. Over to you, ma'am.
Happy afternoon for all the participants. Happy very early morning to our eminent speaker of the day, Mr. V. Subramanian. Welcome you all for the successful day 4 MHRD RUSA 2.0 sponsored International Congress on Industrial Perspectives on Data Analytics. So today we are going to have a very interesting and latest trending topic on advanced analytics in digital twins for healthcare. So I'm happy to welcome our eminent speaker of the day, Mr. V. Subramanian, Senior Technology Manager, Honeywell International Incorporation, Atlanta, USA. So welcome, sir, for joining with us to throw light on this particular topic based on the latest technology to our research scholars, faculty members, and young student generation. Welcome you all for our wonderful program. I take this opportunity to welcome our professors from our own university, our colleague, our supporting colleagues, Dr. Mrs. Swarnam, Dr. B. Lavanya, and our professor, Dr. Kadirvallava Kumar sir, and from government colleges and affiliated colleges, professors, research scholars, dynamic PG students of the Department of Computer Science. It gives me an immense pleasure to introduce our speaker of the day, Mr. V. Subramanian. He has got a rich experience in 30 years in information technology with 2 Fortune 100 companies. He is presently working as a Senior Technology Manager, Honeywell Connected Industrialist. He has worked for companies, namely Honeywell, Caterpillar, and the World Bank. He has pursued his MBA Analytics specialization from University of Illinois, Urbana-Champaign, and he has done his MCA, Alagappa University. I am happy to introduce that he is one of my best friends for the past 30 years. I am happy to welcome you. When the day 1, I approached our eminent resource person, he has happily accepted our invitation, and he wanted to give a very good topic and latest trend which is emerging in the current scenario to be focused. He has shown keen interest on this particular topic, and he has updated me from the day 1 onwards. I have approached till the date. He has updated me with his content, other details. So we are honored with your presence, Mr. V. Subramanian, of today's speaker. And I'm happy to introduce his calibers. Mr. V. Subramanian is strategic, focused, proven, and result-oriented technology leader with 2 decades of extensive experience in a myriad of systems and technologies, with a current focus on large-scale industrial digital transformation, connected enterprise architecture, and innovation using emerging technologies. He has extensive experience in architecting large-scale business and technology transformation projects for some world's most innovative companies. His rich experience includes building system software, business industrial applications, and leading innovative IT solutions for very large enterprises such as Honeywell, Caterpillar, Hertz, and the World Bank. I'm happy to welcome you, sir. And I will take 2 minutes time to recap our last 4-day session. We have started our MHRD RUSA 2.0 sponsored International Congress on industry perspectives of data analytics from March 7th onwards. Then the day one has started with the resource person, Mr. T. Sivakumar, co-partner, Deus App. He has thrown a light on data analytics with business intelligence. Then in day two, data analytics with machine intelligence has been focused by another industrialist, Mr. Naveen Kumar, media network software engineer from Hyderabad. In day three, integrating robotics process automation with data analytics, it has been delivered by Mr. B. Saravanan, former director, CTS. So for all the 3 days, our participants have learned a lot. And today is another interesting day, which we are going to focus on trends in advanced analytics, digital twins, which is emerging technology in Industry 4.0. So I'm happy to welcome as well as hand over the session to our speaker of the day, Mr. V. Subramaniam. Over to you.
Thank you, Chitra. Let me start presenting.
Yes.
Give me a second. We all can see this. Can you all see the PowerPoint?
Yes, sir. Yes, sir.
Slideshow.
Thank you.
Slideshow.
Yes, sir. Yes.
Yep. Good afternoon to everyone. I'm really excited to be here. Thank you, Chitra, for inviting me to this presentation. The topic today is a very interesting one, digital twins. I don't know how many of you really heard about this topic or this term, but we will try to get you introduced to this term. Here is the agenda. So I'm going to talk about myself a little bit. Thanks for the wonderful introduction, Chitra. But I'll say a couple of things about me. And we're going to talk about what is digital twin and why is it exciting, right? So we will introduce the concept. We'll talk about some industry trends, use cases, most importantly, some technologies, what basically is needed to build it. We'll touch upon the advanced analytics. I know that's a topic of this session. We'll talk about a little bit of machine learning, artificial intelligence, and deep learning, etc. Then we'll talk about how digital twin plays in healthcare. And then another important topic, how do you get started? Like, where do you start if you want to build one, right? So I'll show you some resources. We'll talk about future of digital twin, and I'll show you the references that I used to come up with this presentation. Finally, I'll give you enough time for questions. If anybody has questions, you can ask. Throughout this presentation, I'm going to show you like 3 videos. They are less than 4 minutes, but I think they are very interesting. If you look at digital twin in YouTube, you will see hundreds and thousands of them. But these 3 videos, I think, are important to kind of make a point. So I'm going to show them. All right, let's start with an inspiring quote. So I'll not say anything. I'll just leave this for 30 seconds. All right, that's me. Again, just to introduce myself, I work for Honeywell, which is a large industrial company. I am in Atlanta. It's actually 4:30 a.m. So I hope you all understand I'm a little sleepy if you see me. So that's the situation here. So I work in different countries. I actually live and work in the United States now. As Chitra said, I did MBA and I did MCA in Harvard University, and both of us happen to be classmates, by the way, long time ago. So that's about me. And I don't know how many of you are students looking for a job. I think I'd like to introduce what our company does. If you have not heard about Honeywell, we are 116 years old industrial conglomerate. We are in 125 countries. We operate in aerospace, buildings, energy, industrial, safety systems, and life sciences. We invent a lot of things. And some of you may be using these without really knowing this. First of all, if you ever see a thermostat in any building, that's actually invented by us in somewhere in early 1900s. I hope you can see it. Chitra, can you see it clearly in the power in the?
Yeah.
Okay.
Sure.
So almost 1 in 3 buildings in the world actually has our thermostats. That's invented a long time ago. Autopilot. If you're traveling in international, if you go to any international countries, I don't think it will be the case if you travel between Chennai and Bangalore. Your pilot will only engage himself or herself during takeoff and landing. The rest of the time, the flight runs by itself, right? So the autopilot was invented by us in World War II time. Then if you ever fill a gas at the gas station or petrol, I think that's what's called in India, is actually the unleaded gasoline is invented by us. And biodegradable detergents, collision avoidance system, like if you're a pilot and if you're traveling in the sky, you don't have a road like the one you drive your car. So the collision avoidance system is the one that actually helps you to not hit the other airplane. So that was invented by us in 1960s. And if you ever see a barcode like this, it's actually invented by us. You may have seen in a lot of products. That's actually invented by us. So that's about us. We do a lot of other things. If you ever traveled in the airplane, you know what landing gear is, that the wheel that comes down. If you travel in any of those Boeing or Airbus airlines, when the wheel comes down, it is likely made by us. It's called landing gear. Auxiliary power units. Airplanes needs to have a lot of power. If something has to go wrong, you need to have an extra backup and things like that. So those are made by us. And I'm sure most of you have heard of block boxes or flight data recorders. When unfortunately in accidents, they are actually being used very well for understanding what happened inside the flight. So the black boxes, whether you're traveling in B series like Boeing or Airbus, that's likely made by us. And last year we announced the world's most powerful quantum computer, and who is world's most powerful often changes. But as of last year, we had a superiority over quantum computers. So that's about us. So in case somebody is looking for a job, if you see a Honeywell advertisement and if you don't know what the company is, this is what it is. Any questions on this before I go to the next one? And we'll make this interactive. You know, at the end of every slide, I'll give you an opportunity to ask questions, as well as I'll give you an opportunity to ask you a question at the very, very end. So make use of it. If there are no questions, I'll go to the next one. Digital twins. If you have not heard about this term, the concept has been there for a very, very long time, almost 50 years. It was used in Apollo 13 space program, that is Apollo 13 taking off. And the term digital twin was not used for very, very long time. It was actually introduced by a man called John Vickers in 2002. He also happens to, at the time, he worked for NASA. It is currently used in many industrial, defense, and medical applications. It is not some new concept. It's there, but a lot of people don't know about it. That's the reality of it. When it comes to what digital twin is, there are, if you really Google it, you'll see hundreds of definitions. There are several of them. And I picked the one which looked very simple to me, which is virtual representation of a physical object. The physical object can be anything. It can be a rocket, it can be a plane, or it can be a car, train, building, or it can be a human being, or part of human beings, such as organs, anything like heart, or I think they're pretty similar to human brains as well now. So that's what digital twin is, and I'll introduce the concept with another use case. That'll hopefully make a little better sense. There are different type of digital twins. We hear like service twin, design twin, process twin, and all that. You'll hear a lot of those terms. I'll explain what those are. It's mostly used in manufacturing today. It started in manufacturing, of course, in rocket science. I use in my job, my team actually builds digital twins day in, day out. That's what my job is. It is evolving in the healthcare side. I think we are going to see an exciting applications in healthcare. The future potential is very, very exciting. It is very, very important for all of us to understand whether you are an IT or not, it's going to touch you in some way. It can be, when you go to the doctor next time, you're likely to see some kind of digital twin working indirectly or directly on you. So that's going to be the state of affairs as far as digital twins. Any questions on this, or you want me to keep moving? Okay, it doesn't look like there's any question. Before I explain what digital twin is, I'm going to play a video. I'm going to play, this video is only for, this video is actually for 15 minutes, but I'm going to play for 4 minutes. Take a look and listen, and I'll come back and explain this, what digital twin is really is. So let's wait for 4 minutes and just listen to this video. Chitra, can you see the video and listen to the audio?
Yes, video is on, but no voice.
Audio is coming?
No,
No audio?
no audio.
Hang on. So you can't hear the audio from the video?
No, audio is not coming, only video is coming. I think you will have to.
It's embedded, but let me see.
Check whether your audio is on properly.
The audio is on. Let me see.
When we share in our Zoom, when we share the video, it will ask for an option whether you want to sync with the volume, whether you want to play with the audio. There you need to give yes, I suppose.
It's in the PowerPoint, or it's in the video. It's in the. Yeah, let me see what I can do. I'm gonna see if I can fix this. All right, I'll play this later. Then let me see if I can fix it. And I put this link in a reference, so you can actually look at yourselves if you want to look at this. But that's an interesting video. He's talking about digital twins.
Or you can play the video and you can give the voice over it. Can you play and you can give the background
Okay,
voice?
let's see. Yeah, without audio, you cannot really understand what he's saying, but
So actually, when you start sharing, it will ask in the window, the left hand side corner, it will say share sound. You need to have to check that box, share sound box.
okay. Oh, there you go. Okay, gotcha. Let's see if it works now.
Yeah. Super.
Can you hear the audio now?
Yeah. It's
Okay.
coming.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
Okay, good morning. What you saw just now was not a glimpse into the future. This is happening now, today. This is a representation of a D11 steam turbine that's currently running in Southern California. We call these representations digital twins. What you saw was an example of the human mind working with the mind of our machines. What's a digital twin? It's a living model that drives a business outcome. So this model gets data, gets operational data.
All right, that's all I wanted you to listen.
Data and environmental data.
All right. The only thing I wanted to take away from that video is he is a vice president of software services, General Electric, and he's basically saying digital twin is already there, right? That's basically the message that I wanted all of you to take. You saw how exciting digital twin technology is. I thought that man can explain better than me what digital twin is. Let me explain the digital twin from the healthcare context, and maybe you can get a little better understanding of what it looks like. Now, I put like 3 areas here. Human with the wearables. You don't have to have all these sensors, but a lot of people seem to have watches now. Right? Let's assume you just have a watch, and the idea behind the digital twin is that you create a digital twin on the cloud. This is step number 1. This is your attributes of a human being, like what is your weight, height, blood pressure, glucose level, and everything else you have about your medical history. You create the model that lives somewhere in the cloud. And then you send the time series data. Like you can send it from any of these devices, but let's say you send it from your watch, right? Then it would send your blood pressure, maybe heart rate, and things like that. And your twin continues to learn about you based on your attributes here and the time series data you're sending every day or maybe like once in a week. It kind of tries to learn who you are and how your health works. And here in the 3rd tier, you have a built of knowledge sitting there somewhere in the cloud. You have a cloud health intelligence, you have a predictive analytics, you have a bunch of doctors feeding data into the knowledge system. And it continuously tries to learn about you and how your health works. And at some point, if it detects anomalies, it tells you that something is going to happen. In this particular example, it's basically telling you that, hey, it's going to, you're going to get a heart attack and you need to go to emergency now. And I've informed your doctor already. This is actually a scenario that's playing out today. So this is not some future concept, right? And this is important to understand. This is the most important slide in this, right? So what digital twin is basically this thing that sits in the middle in the cloud that is digitally representing you as a human being, right? That's an idea of digital twins. And as in order to illustrate the concept, I put 4 steps. Step 1, you have to create your model. You have to feed a lot of information about medical data and physical data, and then continue to send your healthcare information, and let the digital twin learn. I mean, this is the area where a lot of your speakers in the last 3 days talked about it, in the machine learning, predictive analytics, artificial intelligence, and few other topics. So, and collectively, that's what is used here to learn and understand what is considered anomaly, like what is considered a problem in your particular situation. Keep in mind, it also looks at several people in the world, like here, like you, and getting the same type of symptoms. And based on its knowledge, it can tell you whether you are going to have a problem or not. So that's basically an idea of a digital twin in healthcare. And like the speaker said, the digital twin idea has been there for a long time. It's mainly used in industrials like the one that I work. GE does a lot of work in industrials like airplanes, turbines, and all that. But that's basically this little concept behind that, right? If you understand this, you understand digital twins, right? I know it sounds like a simple concept, but it's really complicated in the sense that you need to get a lot of things together in order to make this chain happen. Is that clear to everyone? Any question on this before we go to the next slide? Because if you don't understand this, digital twin is not going to make any sense.
Yes, sir. How the IMU sensor work?
Yeah, I think the international IMU sensor is, I think it's called International Measurement Unit. That is like your heart rate, blood pressure, and things like that. Like if you have a smartwatch today, I think Apple Watch does it today. If you have it, you can send it to cloud. I have an Apple Watch. It actually sends a lot of my information to the cloud. I can look at my phone and understand how my blood pressure has been going. This is a common thing that I think is available to a lot of people today. IMU stands for International Measurement Unit. Basically, it means that everybody in the world is sent in the same units, like your heart rates, BPs, and whatnot. Is that good? You got your answers? No?
Actually, sir, it is showing inertial measurement unit. What is that IMU? Is it related to that?
So IMU is, think of like your heart rate, your pulse rate, or your blood pressure. Those are all considered your IMUs. The acronym stands for International Measurement Unit. I think that's what it stands for. Good?
Okay, sir. Continue.
Yeah. So I will come back to that, but IMU simply means it is sending you, your attributes, like the physical attributes happening every day to the cloud. That's basically what it is. Your smartwatch does it today, whether you have a Samsung watch or Apple Watch, you have it today. You can look at that. All right, this is another view of digital twin. This is a little more industrial side of things. This is a simple view. So this is basically an idea. You have a real system. It can be a car, airplane, or a turbine, or whatever. And you have a virtual model here, which is your digital representation of what it is. And the data goes in frequently, and the information comes up. That's an idea behind the digital twin in a different context, right? When you talk about data and information, we know process data is an information. The information is an intelligent direction to this device. For example, stop the car. This is overheating. Maybe a direction or a command coming to the car, or something else. It's trying to tell the moving vehicle, right? That's basically what this idea behind that is. In order to get to this information, you need to run advanced analytics, right? That includes all your algorithms, whatever has been talked in the last 3 days. You have to have the brain to basically make sense of what this data is telling, and information has to flow back to the actual physical system. Again, that's the different view of what digital twin is. There's a little detailed view. If we take this machine, it's the same thing, but it's just trying to illustrate in a little better picture. But the idea behind that is exactly the same. The data goes in and the information comes out. So that is a key idea behind that digital twins. In order to get the information, you need to really do a lot of things, but that's where the advanced analytics comes into play. The digital twin learns from your data and understands what is right for this, whatever the real system is, whether it's an aircraft or a plane or a car or something else, or even human beings. So the machine learning is a core part of it. So that's basically what I try to illustrate here. Again, this is another view of it. Just wanted to give you 3 different views just to make you understand the concept here. It's the same thing, here you have a physical side, and here you have a digital side. It's kind of reflecting what you have, this process is kind of repetitive, right? That's basically an idea behind the digital twin. All right. When it comes to human digital twins, I'm going to play another video. This is again 3 minutes, I think, just to illustrate the concept of what human digital twin is. Let's take a listen.
Imagine a future where personalised healthcare will provide every individual the right type of care in the right way and at the right time. Imagine that every patient has a digital twin, a virtual representation of his health status. Let's explore how this could play a significant role when Mr. Clark, who has been diagnosed with atrial fibrillation, is seeing Dr. Sullivan, his cardiologist. Although AF is a highly prevalent disease, it can be complicated to decide on the individual treatment strategy for a patient like Mr. Clark. This is where his digital twin comes in. It starts by using Mr. Clark's medical data to create a patient-specific biophysical model, including a virtual version of his heart, which looks, behaves, and reacts just like the real one. Through a seamless flow of data and advanced analytics capabilities enabled by Philips HealthSuite, Dr. Sullivan can connect Mr. Clark's digital twin with intelligence on similar cases and select ablation as the therapy with the best possible predicted outcome for him, both on the short and on the long term. Dr. Sullivan carefully plans the procedure by simulating various ablation scenarios on Mr. Clark's digital twin. This enables her to select the one with the optimal computed result. The chosen ideal scenario forms the basis for real-time intervention guidance. During the procedure, all taken actions, as well as any unforeseen situations, are processed real-time into Mr. Clark's digital twin to redirect if necessary. As a result, Mr. Clark received his treatment at the right time, in the right way, with the best possible outcome. This is one of many potential cases in which the digital twin adds value to the healthcare system. From personalised diagnosis and therapy selection to procedure planning and guidance tailored to the patient's physical characteristics, medical history, current condition, and future needs. Innovation and you, Philips.
Oh, that is Philips advertisement, but that's kind of tells you the story of what digital twin, especially in this case, they talk about the heart conditions, right? Digital twins isn't exciting, like I said. Why is it exciting? So let's look at some comments from some big industrial companies. Here you see Lockheed Martin, which is a big industrial defense company here in the United States. It's talking about top 6 prominent technologies for the future of defense and aerospace. And Gartner, if you heard of Gartner, they're big consulting here. They're talking about digital twin being top 10 promising technologies for this decade. Of course, this was in 2019, but that's still true. New paradigm for decision-making in healthcare. Like you saw in the previous video, it's going to change how people make decisions on when to run a medical procedure. And when it comes to money, digital twin is going to have 10 times more market value by 2025 compared to what it was a couple of years ago, right? So it's going to be around $35.8 billion in next 2 years. The company is developing digital twin technologies end to end. There are many of them. Obviously, you saw GE, the man talking about their digital twins. IBM, Siemens have a healthcare component that does a lot of work in that. Honeywell, that's of course a company that I work for. We build a lot of digital twins. We build a digital twins for oil wells. We build a digital twin for airplanes, buildings. If you see anybody have heard of Burj Khalifa? That's in Dubai. That's the tallest building in the world. That's controlled by our systems. There is a digital twin that basically controls that. Sydney Opera House, anybody has gone to Australia, that's our control. That's a building that's controlled by our systems. And of course, you saw Philips. They were talking about the digital twin and how it's going to change people's lives. Digital twin is playing a lot of areas: energy, production, health and wellness, aerospace, smart cities, telecommunication. You name it, it's going to be there everywhere. It's already there everywhere. So that's a state of the digital twin today. Now, so let's talk about some industry use cases here. So when it comes to industrial production and manufacturing, there are 3 areas that I think is mainly digital twin is playing out. One is industrial production and manufacturing. That's the area I'm in. You can use digital twin before producing a particular item. Let's take a car, for example. You can just use a digital twin to actually simulate, to understand how it will behave in different conditions. If you run 100 kilometers per hour, what will happen to this car? You can actually simulate without even making the car, right? That's before production. You can simulate and learn the behavior of the virtual models, and you can make a lot of decisions before you make it, right? You can tell how this car is going to be actually when you start making it. That's an excellent use case. Perfect the production and performance until it goes to production. So you just keep tweaking until you really see that all your performance problems are solved. After production, you can collect the data in real time, and you can run a predictive and descriptive analytics. You can say, for example, whether the car is going to fail. If it's going to fail, what do you need to do, right? And you can tell the customer or the driver before the car actually fails, and that's one of the common industry use cases. And that's an area I work in. So it's called asset performance monitoring. So what we do is we basically monitor a lot of assets in real time and tell people before it fails. And that's the coolest technology that digital twin helps us to realize. Then in healthcare, you can emulate humans or human organs. You just saw an example of it. And we can like in machines, you can also look at your health, and you can fix a lot of issues before it actually happens. Can we prevent a heart attack before it happens? It looks like you can, just by looking at some of those videos. And even going beyond the human body, you can look at the medical devices such as MRI machines, and you can have a digital twin and kind of understand what they are trying to tell in terms of how the physical machine is operating. And most recently, I think Singapore announced that Singapore is making entire city as a digital twin. Here is a picture of Singapore digital twin, and you can Google that. You can see it in the news. Singapore is the first country or city, in fact, to run the entire city in digital twin. So that's exciting. I think it happened sometime in the last year. So that's interesting about the digital twins. And obviously you see here a digital twin. There are real side of things and the digital side of things. It is trying to help you to become a better person from a health perspective by running your digital twins and constantly learning about you. And not only that, just consulting the knowledge that's out there in the world and trying to figure out, person like you with the same attributes, if they had a problem with similar data, and you can tell you that, hey, I have a person in such and such place and they are different problems. They seem to be exactly having the same attributes of yours. So just watch out. So those are the things that is going to help us going forward. All right. Again, this is another view of digital twin, the value of digital twin in the healthcare. As you see here, I think we are patients and payers in most cases. If you really look at a patient, it is going to help you in wellness and lifestyle, risk assessment, understanding and diagnosing your problems, and treatment option, what is your best treatment, and monitoring the recovery of your compliance. And then, of course, sometimes you are a patient and payer, but sometimes your parents are your payer, but if you're not a payer, your parents are going to benefit as well. So that is, I'm not going to read out all this, but there is a significant amount of benefit comes out of digital twins. And in here, I was trying to put a little concept, Swedish Digital Twin Consortium basically showed. And an example they are showing is here, you have they're creating multiple digital twins of one patient. They run a different simulation to see which one or which treatment is actually best for this person to give. You can look at this example here. The individual with the sign of disease is red. They simulate with the different medications, and whichever one it works, and they take it and give it to this person. So before doctor even prescribe you medication, they can actually simulate what is going to be good for you by using digital twins. So that's another pretty intriguing use case. And in the bottom, I have Siemens basically saying they are basically simulating the patient's heart and allow cardiologists to precisely place where it needs to be, right? And before it actually goes to the surgery, they can tell what is it going to happen and where to place this heart. And that's, again, it's an important, heart surgeries are very expensive and you need to do it right. So digital twins are going to help people do it right. So any questions before I go to the next slide on this? All good? Does that make sense? What digital twin is? Okay. Silence is good. All right. Let me go to the next slide. Let's talk about some technologies here. There are a lot of technologies. Digital twin is not a product, right? It is not a product that you can go and buy. It is a collection of technologies. There is a lot of technologies that you see in the screen. Augmented realities, virtual realities, simulations, cloud computing, and Internet of Things, data integration. So there's so many different tools you need to understand how they actually work in order to build a good digital twin. So it's not a thing that you can go and buy anywhere, right? So that's where you need to be a good computer scientist to understand what digital twin is, and more importantly, how to build a good one, right? So there are a lot of technologies here, but let me take you to the next slide. If you take any book on digital twins, you will always see first 2 chapters talking about fourth industrial revolution, also known as Industry 4.0 or Factory 4.0. Like there are the different terms for us. So let's talk about what is industrial revolution here. It's fourth industrial revolution. And like I show here, you are already here, whether you know it or not. So let's look at here. The first industrial revolution happened in the steam and water power, steam engines. If you see some of the older trains in India, they had the steam engine. So that is the first industrial revolution. And the mass production, like Ford started building cars. There is a second industrial revolution. So there's a mass production and they go through the assembly lines. And the third revolution is electronic and information technology. And I think somebody talked about robotic process automation yesterday. It kind of falls in this area. So you automate a lot of things using IT and automation. We are at the fourth industrial revolution. The key is cyber physical systems. So your systems are actually always connected and always intelligent, smart. They like you. They always connected to the internet. That's an idea of fourth industrial revolution. When you talk about fourth industrial revolution, there are several technologies that makes what fourth industrial revolution is. Sometimes you see I 4.0 industry, INDUSTRIE 4.0. This is actually a German term. Originally, the term was actually formed by some German engineer. So you'll see some German version of Industry 4.0. That's where it originated. So if you see INDUSTRIE, that's a German version of Industry 4.0 industry. You will often see that when you read a book. And there are several technologies. It's a conglomeration of technologies in order to build a fourth industrial revolution based devices, systems. Industrial Internet of Things. A lot of people heard about Internet of Things. What I do is Industrial Internet of Things. That's our main job. The difference is that we deal with a lot more data, bigger machines, and your watch is your consumer IoT, and the large airplanes and manufacturing plants are industrial Internet of Things. There's a complete different technologies on how they communicate to the cloud. There's big difference between. So industrial Internet of Things is something that we all need to understand what they are and how they actually work. Cloud computing is, I'm sure all of you know, high performance computing is one of those important things now. You need a lot of power to compute and operate machineries. In-memory computing is a big deal. And big data is something that they have been talking in the last 3 or 4 days. So you all know what big data is. So those are the things that's going to be important in order to build a good Industry 4.0 product. Then you have a consumer IoT, medical devices like your smart watches. And they also play into that. Then edge computing, fog computing, mist computing. The mist computing is kind of new. I think that's a firmware that happens in your devices. Edge and fog has been there for a long time, but that's a new term called mist computing. So that's being thrown around recently. Then data science, and the most important thing is the data science. Right? When you look at the picture last time, if there is no data science, artificial intelligence, or deep learning, the digital twin itself is meaningless because it's going to just tell you nothing. So that's where the advanced analytics comes into play. Supervised and supervised reinforced, regression, classification, clustering, dimensionality reduction, PSA, and all that thing, right? So all of these collectively make you to to be prepared for building a good digital twin. So you have to understand all of this. Single one of this is not going to help. You have to understand everything collectively together in order to build a good digital twins. In my daily work, we actually simulate, we actually build a large digital twin for a large oil and gas plant. And it's pumping millions of barrels of oil. And we actually operate using digital twin. And we tell people before it fails and before it, for example, it's not producing enough oil for a given day, we will know why it is and what needs to be done. The digital twin actually tells us. So that's something that I do it every day. Any questions on this? Okay, silence is gold again.
Participants, if you have any questions, be interactive. Kindly be interactive to learn more about the technology.
Yeah, either I'm completely good and making sense, or you don't know anything about this. So it's one of those. So either way, I think it's.
They are following it up. They are following.
Okay. That's good. That's good. Let's talk about how to build one, right? So it's all exciting, but how are we going to build? There are some reference architecture I put it in. You need to understand how to acquire data from sensors. That is where industrial Internet of Things. You need to have a scientific understanding. There is a term called physics-based modeling now. I'm sure a lot of you heard about this versus database modeling, data-driven modeling, I think that's what's called. All of those industrial Internet of Things is basically a physics-based modeling. You have to understand in machine learning, in a data science, there is a term called physics-based modeling. That's something that if you have not heard, just try to look into this and understand, because the entire digital twin is driven by physics-based modeling. Your model creation and deployment, like you saw in my first slide, you have to create a model, which is the real physical representation of what your object is saying, and put it in the cloud and protect it, secure it. And at the right-hand side, you have a deployment of healthcare digital twins. You have a patient and sensing data and acquisition, like you saw in my previous slide. You have a bunch of devices that basically measuring and creating a data that the computers can read. Then you have a model, the computational model about you. Then it's reporting and visualizing about what is happening to you. This basically will depend on what kind of use case we are trying to address. We are trying to address your brain, your whole body, or part of your body. So it all depends on what we are trying to address. But the fundamental idea of this data flow remains the same, regardless of what digital twin architecture you are trying to build. Again, this is a simplistic view, but that's basically what the sequence of steps that you need to take in order to build a good digital twin. All right. And I think we are, you may be wondering, it's all interesting and good, like, how do I build one? Where do I go to understand what digital twins are, and how do I learn about it? I mean, that's the most important thing for this conversation, I think. Like I said before, digital twin is not a simple product or tool or technology that you can go and buy somewhere, right? It's an integrated idea from varying emerging technologies. You have to understand a lot of things like connectivity, cloud, data and decision science, user experience. So your GUI building, how you are going to build a guided user interface for the customer. It can be a SMS, it can be a dashboard, it can be in your phone, but you have to understand all this collectively together in order to build a good digital twin. If you want to be in understanding, if you want to be in that field, if you want to understand and build digital twin, here are the things you need to do, right? You need to understand industrial Internet of Things. There are books written on this topic, many of them. Understand what industrial Internet of Things are, which is completely different from your consumer Internet of Things. They have they are completely different technologies, connectivity, and how they communicate to the cloud. So you have to understand industrial Internet of Things. Machine learning, of course, many other speakers before me talked about this. I think this entire session is about machine learning and artificial intelligence. Understand how your machine learning models are going to learn about the data that you give them, and then what kind of information they're going to give back to you. There is something that we always miss as a computer science graduates. We do not pay a lot of attention to statistics. And I think that's becoming very, very important now. You needed to understand regression, confidence intervals, principal component analysis, many hypotheses, and all these things you need to understand, because statistics is becoming the most important pillar of this computer science today, especially in the world of artificial intelligence and machine learning. And this is really important for the building digital twins, because if digital twin is not making a smart decision, that is basically meaningless, right? That's what we're trying to accomplish here. Cloud computing is absolutely important, because everything that you saw in the previous pictures, they all run in cloud, whether you pick AWS or Azure or some other technologies. You have to understand the cloud computing in order to really build it. Without cloud computing, there's nothing. The digital twin, the idea of digital twin itself is again meaningless. There are a lot of other enabling technologies that depends on the use case you're trying to build. It is important to understand collectively what digital twin constitutes. Just to get you started, I put some resources here. I can paste this in a chat, or it is very simple. You can just go on to Google Microsoft Digital Twins. It'll take you to this page here, something called Quick Start, and they have everything that you need to start with. They explain what digital twin is. They explain how it works. And I think if you're a student, you can get up to $200 worth of Azure account. You can actually spin some resources and test it and see how it works. So start there. There are many resources. Like if you Google it, you'll find hundreds of them. But it's easier to start with Azure, because they do some free accounts for students. At least they do it here. I think you need to have .edu email account for you to get it. But I don't know how that works in India, but something you may want to explore and see, to really want to learn how that actually is being built. Now, to tell you this is not what we use in a real life. We do not use any of those, what is shown in Microsoft Azure. This is actually a new thing. I think the digital twin in Microsoft has come in the last 1 year, but we have been building digital twins for like 10, 15 years. So our technologies are slightly different, maybe older, but in practice, if you go to the large industrial companies, that is not they will be using, but going forward in next 2 to 5 years, this is probably going to be the way in which digital twins are going to be built. So this is an important research. Pay attention to that. Any questions on that? Everybody's following? Clint? No questions? Looks like I'm doing my job right. Okay.
There is a question in the chat. How digital twin can be used in automation? Automobile.
Yeah. It's actually used today. Something called A2X. If you Google the term automobile to everything, I think that's the term they use. Let's play a scenario where automobile is used. If you ever heard of Tesla, when they build Tesla cars today, they actually, before they build, they use digital twin to build it and actually test it out on how it's going to work. That's one use case. And even the car, after it's produced, it's running, Tesla car is basically a bunch of computers, digital twins. Actually, it is actually connected to the cloud. Now, there is one example you'll see if you look at there's a YouTube video there. So what they are saying is, if Tesla learns from one particular conditions on how to drive, especially when it comes to autonomous driving, it can be anywhere in the world. If it learns a specific style of driving, and that particular style, Tesla uploads to the cloud, and the digital twin downloads to all the cars. So that is how the Tesla cars are actually learning today and how to drive by themselves. So that's one example. Does that make sense?
I have a doubt, sir. How about the storage of it? Like, if you're going to, like, if it's really going to create a revolution in the healthcare industry. So how the data, like, are we going to have layers of cloud then?
Repeat that again. I couldn't hear it well. Are we going to have a lot of data?
Yeah. So are we going to have layers of cloud, like we had layers of disk to store earlier? So this is definitely going to produce huge data, huge volumes of data.
Yeah.
So
That's a good question. There's a term that's thrown around called data lake. You've probably heard of this, right? Data lake is basically an idea of storing a lot of data, and sometimes it's not processed, but it is going to create lots and lots of storage requirement. Yes, but storage is the cheapest commodity today, right? Storage is, if you really look at your computer, storage is the cheapest. Everything else is expensive. So storage is not a problem.
Yeah, but that raises the question on green computing, right?
That hang on, let me change that makes a question on which one? Mist computing?
Green computing, sir.
Green computing. Oh, okay. That's a social aspect of So I saw yesterday that how Microsoft is building their data centers green. AWS is doing the same thing, right? The concept of green is something we need to leave it up to the cloud providers. I think they are going green today. So there's not much we can do as a developers in order to be green. But I think the companies that you are building, Microsoft is definitely showing, I think there are 50 of their data centers are green today, they are saying. And AWS is saying the same thing, but they're trying to build the green data centers all over the place. So you can look at the news there. They are doing it. So I don't think we need to worry about this. That's the whole purpose of cloud computing, right? For technical, social, legal, governmental, we want to rely on the cloud provider instead of we taking care of this. Like if there's no cloud, we should be doing all this, right?
That was my second question, sir. Like, what about the legal part of it? Like, it really sounds to be like it develops a digital twin and it gives us a customized treatment procedure and so on.
Yeah.
So the legal part of it, like, is it real legally, like, is it on or is it still in the developmental stage?
No, legal is it is legal depending on the country where you are in. In the US, for example, the patient has to give something called HIPAA form. They basically need to give a consent that it is okay to have the data stored in the cloud, right? We actually sign every time we go to the doctor office. And if we're talking about the defense and aerospace, that Honeywell, my company, does it. If you heard of something called FedRAMP, FedRAMP, that's a governance, that's a security certification that cloud provider actually has to give in order for us to run a defense and federal products in the cloud. So that's an example of how the government and law and rules actually taking place. When we deploy today, Honeywell is a company that we do a lot of work with the Defense Department. When we deploy something, we have to go something called GovCloud, government cloud. That cloud is not the same as that you see when you go to console.azure.com. It's a completely different cloud. It has a lot of certification. One of them is FedRAMP. And that certification kind of covers our legal side of things, right? So in the government side, there are rules. you have to put and deploy in Gov Cloud, what we call government cloud. And in the consumer side, the consumer has to agree, and they are okay with their data being on the cloud. So yes, you're right. That's a good question, but you have to agree to that data being there if you really want to take advantage of the digital twins. Again, it depends on the country. Every country has different rules in terms of storing data. If you go to Europe, for example, there's a GDPR, and China has a different rules. I don't know what the rules are in India, but it is subject to the country that you operate, right? So that is basically where you need to rely on your rules. But you're absolutely right. It is legally challenging. And I'm going to play another video at the end of it. I think you will have an answer. I think there's somebody talking about that. Good?
Yes.
There's one
All right. Any other?
chat box, sir. How
Yeah.
digital twins can be used for smart farming?
Smart farming?
Yeah.
I have not heard about smart farming yet, but I think it is spreading all over the place.
Agriculture. He's talking about agriculture.
Yeah, I think if you go to Israel and places like that, there is a way they actually water the plants. Like you may automatically water the plants. And the thing that I can think of is you place a sensor in your field. If the water level decreases, it automatically tells your digital twin automatically monitors and tells your system to water. That's one use case that you can think of in smart farming. I think it is already happening in Israel. So I read some stories in Israel. They actually do it because they have very scarce water supply. Again, think of this: you have a sensor in your garden, and if the water supply is going below the required minimum, then the digital twin understands, and it is below, and it gives the instruction to the actual water sprinkler to water the plants. Right? That's I think that this is even before digital twin. This was happening, at least in some cases that I've seen. But that's one good way that digital twin can be used. Think of digital twin as basically understanding what is happening in the real life and constantly monitoring, right? In order for that, you need to have both information flow in both sides. So I think that is the way that smart farming can be, taking advantage of those digital twins. Does that make sense?
Okay, thank you. You can proceed.
Yeah. Any other questions? All right. I might be doing very good then. So this is where you learn, right? This is how you learn. If you're a student, if you want to build one, here is your slide. And take a look at it, just experiment with it, understand, play with it. You are likely to have a good job at some point of time when you're looking for a job. I think that the next slide is actually the last one, I think. Let me go to the next slide. Here are the references I used. There are a lot of references. You saw Siemens examples there, IEE, Microsoft. I'm going to play one other video, and that kind of addresses some of your questions. And you may want to look at this one, 21 ways medical digital twins will transform healthcare. And this is I pulled something from this one, but they have a pretty extensive documentation on how this is going to help the healthcare. So if you want to look at that, you can always look at that. There are a lot of books. You can look at some of these books that I actually have in my library. So like I said, I have to learn this every day. So there's so many books that you can read. If you have to pick one, I would pick the least expensive one. So these are all, I think this is like around $80 or something like that. But start with something least expensive, and there are a lot of resources in the web as well. So That is the end of our presentation. Chitra, how long it took for us to run through this?
So we can go for another 10 to 15 minutes. And if you have any input, you can project. And if anybody is interested to have some queries, question and answer session could be go on.
Yeah. So I have another video to play because that's going to answer some of our questions. That's going to give a good definition of what digital twin is and where it's going. That is the video. So I will play that video. Let's listen to that.
Right now, each of us has a digital twin that's gestating in the digital cosmos, a digital twin of yourself generated through AI, and that digital twin could, in fact, represent you in the digital world. As we live our lives and as we quantify ourselves, we're uploading and digitizing our consciousness, our experience, our sensorial bodies. We're constantly putting that data into the digital world, and eventually that will be gathered by an AI and will become your digital mirror self, your digital twin. So traditionally, the idea of the digital twin is an industrial idea. It's something that companies like GE are using to monitor assets in the real world. They are simulating versions of real assets like hospitals and airplane engines, and they're using that simulation to monitor the real assets in the real world. So the industrial idea of the digital twin is not what I'm talking about here. What I'm talking about is the future digital twin of the self, of the person. Who we are in the cosmic digital world will be a digital twin of us. The way that we get there is through quantification of self down to the molecular level, where suddenly in every scenario we have data, and that gets sent directly to the digital self. And that is what we're going to see in the future. Every time we upload any content, any data into a social network, anytime we use our credit cards, all of that data gets implanted into the digital system. And even though that system is fractured right now, even though data is going to a social network, or it's going to a credit card company, or it's going to a medical device, eventually those systems will come together. That digital twin will access that information and represent you in the digital world. I think it's an interesting question to talk about what happens to your digital self or your digital twin in the future when you pass away, when your physical body passes away. Does that digital twin get to live on as a simulation? Does it get to interact with other entities within the virtual space? I think that what's going to happen is that those entities will be able to live on. So for example, if you have a deep neural network brain-computer interface chip implanted into your brain, if you are wearing a smart wearable device or a smart suit that quantifies your heartbeat and your body temperature and how you react to certain environments, all of that data can be generated and loaded into an AI system that represents your digital twin, that can crunch that data and form a sensorial profile that represents you and who you are and how you behave. In the future, what we're going to see are variations of self. Imagine having an app or an operating system for the digital twin in the future where you can adjust the behavioral platform and the behavioral psychology of your digital twin for different scenarios. So maybe there is a digital twin that is the professional self. There's a digital twin that is the romantic self. Each of these incarnations of the digital self in the future can be adjusted for the scenario that you're working with. And when we get to the digital world where we have the ability to adjust those things and have those digital twin selves constantly representing us in different scenarios, that's going to be a very interesting future, because then you'll have different reputations for different digital twins. Different digital selves will have different reputations. The future is more complex. It is more diverse than the space that we're living in right now. Once we cross over into the digital plane, into the digital cosmos, and we start playing there more than we play here, which is going to start happening because of VR and AR and all those things. Once we start playing in that space more than we spend time in the real world, quote unquote, things are going to get really interesting. So this is the real Black Mirror scenario, is that your digital twin becomes so advanced that it takes off without you, that it stops wanting to have anything to do with you. I mean, imagine that suddenly it becomes self-aware, this digital twin becomes self-aware, and it says, I don't want to behave the way that you want me to behave. I want to have my own experiences. I want to have my own desires. I have my own goals and desires. In that case, then suddenly you have a rogue self that has mirrored you, that exists in the digital world that you may not have control of anymore. These are all scenarios that will probably play out in some form or another in the future. And the idea that we could lose control of the digital twin, that we could lose control of the AI, and what happens when that digital twin wants to procreate? What happens when that digital twin decides it wants to create other digital twins of itself? And suddenly you have hundreds of you inside the digital world that have their own desires, that suddenly want to go their own way and don't want to be controlled not only by you, but it doesn't want to be, those don't want to be controlled by the.
All right. I think what he is trying to say there is there are a lot of problems likely to happen, right? One is legal, and what happens if a person dies and the digital twin exists. I think this was Dr. Lavanya was asking these questions. I think he is trying to answer some of those questions. Any new technologies, that's going to be a problem, right? How we actually use it.
It's really scary, right, sir?
Yes. Any technology is scary, right? I mean, the internet came, it was scary, your smartphones are scary, but it all depends on how you use it, right? How well we use it. There are good and bad in every single technologies that comes out, but hopefully we use it for the right purpose. But the reason I wanted to play that video was he's talking about a good and bad, right? In future, it can go out of control, right? It can, you may lose control of it, but I hope we can find an answer to all those questions and stop them before they go wrong. So, but there was an interesting perspective about the futurist, how he's talking about the idea. This is our last opportunity. I put this little quote. Just pay attention to that quote. If you have questions, I'm glad to stay on and answer.
I have two questions.
Sure.
First question is, compare robotics with digital twin. Robotics, compare and contrast.
Robotics. Yeah, robotics more of physical. You have all the control systems within the physical device, right? It rarely connects with internet, at least as of today. You take any robotic systems, whether it's the vacuum cleaner or really the robot that brings your food, it's all internally controlled. The software is embedded systems, right? Whereas digital twin is mainly driven by the cloud. The digital twin itself is meaningless if it doesn't connect to the world, right? That's a difference.
What would be the automations? Everywhere people are talking about intelligence and fifth generation, sixth generation, everything. What would be the manpower? Will it?
You lose the job.
Yeah, will it replace?
Decrease the scope of the manpower requirement in certain industry applications.
Right. So let me go back here. I think that's a good important question. So in this, if you really look at the stack, every time the revolution happened here, people thought they are going to lose job. Every single time in history. Like when the second revolution happened, people were doing the steam and water power, they thought they would lose job. But they found newfound ways better themselves. In fact, their lives have become better. Same thing true here. When the third revolution happened, a lot of people were worried that they're going to lose some mass production like that. When the fourth industrial revolution happened, a lot of people in IT and systems and automations are worried. But historically speaking, there are philosophical books and economics books in this. Historically speaking, every time the next revolution took place, people's lives have gotten better. In fact, there were more jobs than the previous generation. You can take a look at that. There are a lot of examples. So the answer to this question is no, you're not going to lose your jobs. In fact, your lives are going to become better.
Okay, fine. So how do the students community can strengthen their job market in this technology, specific technology? How do the students strengthen their skill set?
How they can get a job? Is that what your question is?
Yeah. How,
Simple, that's how to get it. Right.
Okay, here's what, this is the slide I was trying to explain that, right? I was trying to give the answer to that question here. Like I said, the digital twin, if we're talking about digital twin, it's not one single thing. You know, they have to understand whatever the previous speakers in the last 3 days spoke about, different things, automation, machine learning, understanding the machine and all this. So here's what they need to understand. That's what I was trying to explain in the last slide. They have to understand industrial Internet of Things, the connectivity. They have to understand the machine learning, how this supervised, unsupervised, reinforced, all this works. Statistics is important. Like in the past, the computer science, I think numerical methods we had in the 90s, but nobody ever paid attention to that. I think it's called numerical and statistical methods. I don't know if you still teach, Chitra, in the colleges.
It is there, but statistics and everything is we are teaching.
Yeah, so none of us paid attention when we went to school, right? We just passed it. We wanted to pass it.
Even know the same thing, sir.
Yeah, okay. It was the most boring subject, so we wanted to get 50% or whatever to pass it. But now you think about it, that particular subject is really, really important to my job. So, you know, to talk about me, a lot of things I go back, 30 years back, and when we went to college, I picked a lot of things from statistics and numerical methods to do my job today. The technology has improved, the concept is still there. So by then, I didn't know why I was really studying that. Now I do understand after a long time. So they have to understand statistics very well. Cloud computing is, of course, new. I don't know if you teach in the college or not, but they have to find a way to, the one way to go and learn cloud computing is to go and sign up to Microsoft Azure. The students get a free discount for $200. They can do a lot of things to learn that. I would really encourage people to go and sign up for the cloud computing, Microsoft Azure, just play with it until you exhaust that $200, and then you can delete that account. So that is my advice, right? They have to focus on a lot of these subjects. They are meaningful today, and some of those may not be in your curriculum, but they need to understand what it is by going beyond what is taught in colleges. Does that answer your question?
Yes.
Yeah. So it's a lot of things. I mean, it sounds really hard, but once you try to understand and connect the dots, it will make it easier.
Sir, actually, in industry, like in which stage is this digital twin, sir? Like
Yeah. Digital twin you saw like in 2002 is when they actually coined the term digital twin, right? So let me go back to that slide.
2002, yes.
All right. If you really see, it's been used since 1960s. Of course, the only difference was that at the time there was no cloud computing. They were using different technologies to do exactly the same thing. If you see digital twins, it's been there since 2002, which is almost 20 years now, right? It's been there. Now, how many people have heard about this? I don't know. Even, I go and teach colleges here. I go to guest lectures. I ask people in the actual real classes, how many people have heard about this? I hardly, a couple of hands rising, right? So people have not heard about this. Even big companies like ours, if you go to another part of the company, people, this is the first time they're hearing if they tell them what digital twin is. So it is there. It is only used in the most advanced industrial companies, such as GE and Honeywell and like us, Philips and whatnot. But I think it will come to you in some form pretty soon, because the change is taking place pretty exponentially. So you are going to see it in some form. It may be there, you may not be even realizing. Yeah, we do it. I mean, that's my job. For the last 4 years, building digital twin is my job. So at least last 4 years, I can tell you that I've been building digital twins.
Can you suggest any research-oriented applications in specific domain of digital twins? We have been elaborated and broadly understood everything. Can you spell out some challenges which is really existing and to be focused by the students, research students?
If you really look at the percentage of digital twins, almost 80% of them are in manufacturing. If you are a mechanical engineer, the CAD, when you design a product, CAD, CAM, and all those things, that's where the digital twins are playing now, right? Before actually manufacture, like I said before, you actually design a product in CAD and kind of simulate it using digital twin and see how the product is going to actually work in real life. That's one area. If you're an IT, all you can do is you can understand the emerging technologies and the list of technologies that are needed to build the digital twins. Like the area is probably mechanical engineering. If you want me to pick one area, specifically manufacturing is where it's going to have a lot of value.
Okay.
We use it in aircrafts. If you see a flying aircraft, all of them are digital twin. Helicopters, we make helicopters are digital twins. And there are remote helicopters now. They are all operated remotely. If you really heard of drones, not the drones that kids play, but the real drones used in military applications, they are all digital twins. So there are many applications. But if students have to pick one, I would say pick an area of manufacturing.
So the role
yeah, go ahead.
The role of information technology, people will have to focus on the software then to talk about machine intelligence, machine learning techniques, architectures to be focused, right?
Yeah, there is a term that's being used
Cloud
time, but I don't know if you, there is a term called OT, right? Operational technologies, and IT, information technologies. In order to build a good digital twin, you need to understand OT and IT, right? IT is alone not enough. Is that the term familiar to you? What OT is, operational technologies are? No?
No.
Okay. The term OT is being used many places in industry. So if you have OT plus IT is equal to digital twin, right? Let's put it that way. The operational technologies are your machines, the sensors, the IoT, and how you get data from these machines is what is known as operational technology. So the IT students need to go beyond, learning, for example, Java programming and data structures and all that. They have to really go beyond that and understand how those operational technologies work. Because in future, IT itself is not going to really be meaningful. You need to understand, for example, in healthcare, you need to understand how those artificial hearts are going to work. Artificial human beings, digital twins are basically, again, artificial virtual representation of an object. So operational technologies, if you have not heard about this, just again, Google it and understand what that is, because without OT, IT is not going to be meaningful going forward. So you got to understand that.
Thank you very much for your valuable session and informative session towards.
All right. I'll go one more time. We'll leave some questions.
Yeah. Sure.
Okay. All right. I'll leave this here for next 5 minutes. If there is no question, I'll assume that I've done very well, or I've done really bad. They don't understand anything. So
can I ask a question?
Yeah.
Sir, what is AI in your perspective? Like having done all these, and you are in the very latest technology, digital twin. And so, what is AI in your perspective, sir? Like,
well, when you look at the AI in a book, you will see this big circle: AI, machine learning, deep learning, and all that, right? So AI is basically a superset of machine learning and deep learning. That's a textbook definition, but my definition is artificial intelligence is not limited to that. Artificial intelligence is, my definition is discovering something that is not already there, just innovating something to new areas, right? That's what I call artificial intelligence, especially in our area, manufacturing. But the official definition is, machine learning plus deep learning is equal to artificial intelligence. So I don't know if that's what you need. That's an academic definition.
what may be the next of digital twins, sir?
You saw the future is talking about the digital twins. Healthcare is, I think that's evolving. There's a lot of applications in healthcare. You can simulate yourself in the cloud, and before you get a heart attack, for example, I think you need a lot of diseases can be solved, I think, by proactively monitoring your health. I think that's going to be the biggest application of digital twins. Right? It learns, it understands. If the data goes from a smartwatch, it compares hundreds of millions of people across the world to understand, is anybody have problem like yours, and if there's a problem, what the prognosis was, and that's going to be the biggest deal in my opinion, because health is an utmost important topic. It is also going to play in defense, drones and all those places. There are a lot of advancements in this. Every country is trying to catch up to that technologies. For example, if you see drones, they are a combination of digital twins, deep learning, right? That's what they actually are. They fly around and shoot people and all that, but that's basically a fundamental digital twin. That's one area that we are investing a lot of research. So if you ask me, I would say defense is one area, and the other one is healthcare. I know there are two extremes, but those are the two areas that's going to be a lot of changes in terms of digital twins.
So, like we politically, our lifestyle has been controlled. In next era, I think will be digitally, our mind style will be controlled.
Yeah, I think you are already there. You have your smartphones kind of controlling you today. How many times you look at your smartphone? So I think you are there already. So it may not be the digital twin controlling you, but you're controlled by your smartphones anyway. But that's where it's going.
Thank you for your patient answering, sir, for all the questions.
Yeah. Any other questions from students? Nothing? Okay.
Any other questions from the audience, please? Grab the opportunity.
Yeah, read the code here. All right, I don't mean to put a pressure on them, but I hope they so when I go to academic presentations, I tell only two things, right? My objective is only two things. Not to put people through sleep, right? That's one thing important. I know this is 3 p.m. You probably had lunch around 1 o'clock, and typical time people go to sleep. So, especially when you're sitting at your home with the computers, that's one thing I try to avoid. The other thing is, can you pick 3 terms from my presentation that you have not heard about this before, and kind of Google it, right? And if you understand those 3 terms, what those are that you never heard about, and you just picked up here, I think that's a success. Even if you don't really understand anything about digital twins, the word digital twin itself, you just heard of it. Next time when somebody tells you that, at least, yeah, I heard of this before. So yeah. I think that's probably the objective of these presentations. I hope
your objective is met,
that. Yeah.
Your objectives are met.
Yeah. So I have a very simple objective when it comes to academic presentation. So if there is anybody need to know more about digital twins, how we build, how it works in real life, you can, they have my email IDs. You can always email me, and I'll try to do my best. If anybody is looking for a job, you obviously saw what Honeywell is. It's important. So let's put this again. I'll leave this for 1 second. So if you ever see a Honeywell advertisement, please do apply.
Yes.
It's a big company, and we need a lot of people. And there are a lot of exciting technologies that we invented and inventing now. So I'll be excited. So. Alrighty, anything else? Final chance.
Any questions from the audience?
Hello, sir.
Yes.
Can I say that digital twin cannot replace questions like what I would like to have for dinner tonight? In that case, it cannot actually replace it, isn't it, sir?
Yeah, I mean, digital twin cannot replace the humans, right? That's definitely true, right? It is not, but it is going in that direction, right? How you can create a 75% of you. Again, it depends on what perspective you're looking at. If you're really looking at the health perspective, trying to solve your healthcare issues, you can probably go up to 90% of emulating, right? It is not going to physically simulate your behavior of like a biological aspect of it. But the data that you generate, the data you give it to the digital twin is the most valuable thing, as you see in let's put this. So the most important thing is the data that's out there, and what kind of data you send it to them, and how it basically learns from other people, like other people of similar characters like you. And that is the valuable. The rightmost side is the most valuable. There are a lot of knowledge out there, and how exactly digital twin is going to drive the knowledge for you, right? It's a representative on the cloud that is playing your behalf, right? It's trying to protect you from, in this particular case, at least healthcare issues, right? That's how I see it. Obviously, it's a digital twin. It's not a biological twin, so it's not going to never replace you.
Even biological twin cannot predict, sir. Yes.
So yeah, if you have a biological twins, then I think that's a different problem. But digital twins, you are safe now. And there are a lot of questions like the one that has been asked. Governmental policy, green security. Information security is a big deal. What if the security, your data gets compromised somewhere in there?
I feel that digital twins also have some sort of limitations. They cannot fully function as a human. Right? Way of thinking or suggestions.
Yeah. I mean, you use it, any technology for that matter, you use it for the specific purpose that you are trying to use, right?
Yeah.
No technology solves all our problems, but every technology is kind of find its new ways of solving a problem. Like look at this picture here, right? If there is no digital twin, how many lives would be lost, right?
Yes.
It is life-saving. Right? 20 years
is there
ago.
any data, sir, like a decline in number of heart attacks? Is there any prevention happening because of?
There is something in Siemens Healthliner. If you go to that site, that they have a lot of data in that. I don't have it here, but Siemens Healthineer is a pioneer in all these healthcare technologies. If you go to their website, I think they show a lot of data what their digital twins are able to do. And you can go to Philips too. Philips has a lot of the video, like the video you saw, they have a lot of data on how much of healthcare issues have been resolved in this. I think there is somewhere in the World Health Organization, if you go to their site, there is some information about how twins are playing in the healthcare field. In fact, I read an article that COVID-19, when they build the virus, when they were researching the defense against COVID-19, they used digital twins in many cases before they actually put shots on people's arms. They actually digitally simulated it. So that's something that if you really look at, I don't know how many people know this. The COVID-19 vaccine, at least here, the Pfizer and Moderna, they were actually developed within 26 hours. That's all it took, 26 hours. And your last vaccine, whenever it was developed, it took 5 years. And the previous vaccine, it took 15 years, right? Historically speaking. 26 hours is all they needed to build the COVID vaccine today. Now, it took, 6 months to actually test on people. But before they put it on people, they already know what it is going to do, right? Approximately. And that's a beautiful use case for digital twins. You know, when they tested these medications on people, they tested on, let's say, 3 million people. They have run like 300 million simulations before it actually went to production to see how it's going to react on people's bodies, right? And imagine that's powerful.
Thank you,
So
sir.
take one example out of this, COVID-19. It's just 26 hours, unbelievably faster, right? So digital twins are playing everywhere just to help, speed up those processes. So it is important. It has problems like any other technologies. Your cell phone has a problem if you give it to a kid, right? So it's always look at technology in a positive light. Obviously, you are all computer science professors, so you are teaching something good. But any technology has problems. You can misuse anything. So hopefully, we'll find a right use for this.
Thank you, sir. Thank you very much.
Any other questions from the audience?
Audience are quiet. I think they understood everything that I said. Yeah. I think they understood everything that I said.
They are processing.
Just opposite.
Processing, sir.
Good. Like I said, let them take time to process. As long as they picked up a couple of words, keywords from here, that's good enough accomplishment.
Okay. If there are no questions, shall we wind up?
Yeah. All right. This is hopefully it's beneficial. Like I said, it was my 3 a.m. I was able to manage it without sleeping, so that's actually a good thing. But I hope I didn't put any of you to sleep as well. So thank you very much for listening.
On behalf of the Department of Computer Science and MHRD RUSA 2.0 project, I am very happy to thank our eminent resource person for having spent his valuable time and precious morning and early morning with us to give the topic on digital twins. He has introduced clearly the concept, and he has triggered the mind of young minds to do the research based on this domain. Definitely, I hope and our participants will agree that they have never slept. They were wondering with the topic, and they will definitely go with this topic with in next level. As you are working in the digital twin for the past 4 years with respect to a lot of applications, I'm sure this forum will take this as a keyword, and they will process it, and they will do research, and they will come out with very interesting digital twins in healthcare as well as in drones tracking and picking up, and security. As far as security is concerned in defense, it is one of the very vital thing to be focused by our India as well as in other countries. I hope this particular session is highly an eye-opener for us. Definitely, we have learned a lot from you. So learning is a continuous process. We always agree with that as a professor in the Department of Computer Science. So, katradhu kai mannalavu, kalladadu ulagalavu. This we always give respect to that. Based on that, only our forum also is behind us to learn the concept. So, I take this opportunity on behalf of me as well as Department of Computer Science and every participant. They have taken 2 things from your session. First one, twin. Then they have just processed it, and they will do with purposeful outcomes in the society level. which is useful for the society. So
Thank you.
you have not slept during this particular day, but I hope our students, our participants also will take this, and they have never slept during your sessions. With these words, I'm happy to thank you for the wonderful session, as well as spending most precious time with us in spite of your busy schedule. Thank you so much.
Thank you very much. Thank you. Thank you
Thank
all.
you.
Good luck.
Propose
Yeah.
a vote of thanks, a formal vote of thanks. Bhavani?
Good evening to one and all present here. Change is the end result of all true learning. For me, every hour is grace. It's my pleasure to conclude the International Congress on Industry Perspective of Data Analytics Day 4. I would like to thank our resource person is spending more valuable time for us throughout the session by giving vast information on what is digital twins, cloud-based healthcare, digital twins view in data and information flow, how digital twins plays vital role on industries and healthcare, and etc. Last but not least, I would like to thank all the participants patiently in this International Congress grand success in day 4. I'm sure that you all feel enriched with the digital twin knowledge and enjoy this session. We will meet tomorrow, another interactive and information session on relevance of machine intelligence in today's world by Mrs. Revati Subramanian, Global Managing Director, Data Science Accenture Operations, San Diego, US at 3 p.m. to grab our skill. See you tomorrow. Thank you all.
Thank you.
So thank you, sir. Thank you so much.
Thank you.
The session was really wonderful and informative, sir. Thank
Yeah,
you. So much.
glad to help. Glad to help. Thank you all. Thank you all. Bye.
Bye, sir. So dear participants, we'll be meeting tomorrow exactly by 3 p.m. And the session will go on from 3 to 4:30 p.m. and 4:30 p.m. we'll have our valedictory session. We are going to hear valedictory address from Dr. G. Bhaskaran, syndicate member, University of Madras. Please be here on time at 3 p.m. Thank you all. Thank you all for your patient listening.
Thank you. Thank you.